Hi, in this video, we will be solving logarithmic equations. So let's go. I have placed here on the side some of the properties or laws of logarithms. And like, for example, in here, log of a product, log of a quotient, log of a power of an nth root or mth root, and then some of the other properties. And then below, for a function f of x is equal to logarithm of x base a, we know that a should be greater than 0 but not equal to 1, and that x, the argument, should always be greater than 0. So having all these in mind, let's try solving. For the first one, what we can do is, first, since both of them are base 10, we can just raise both of them by 10, or since both of them now have the same basis, we can just say that 5x is actually equal to 2x plus 9. And then transposing, this becomes 5x minus 2x is equal to 9, or 3x is equal to 9, x is equal to 9 over 3, or simply 3. Now, one of the restrictions in logarithm is such that the argument has to be greater than 0. In this case, substituting x equals 3 in log of 5x is making it positive. This one on the other side also makes it positive. Therefore, I can say that the solution set is 3. On the other problem, we can see that there is negative 2 in front. So maybe we can divide both sides by negative 2 first to just remove the negative 2. So this becomes logarithm of 7x base 5 equals negative 1. And then we do the transformations. 5 to the negative 1 is equal to 7x, or simply that's 1 over 5 is 7x. X, therefore, 1 over 35. Then again, when we plug in x equals 1 over 35 in the argument, it makes it still positive. Therefore, the answer is 1 over 35. Let's go to the next problem. Here you have ln. So maybe here we can do the transformations immediately. So e squared is simply the square root of x plus 3. And then we need the x there. So let's raise both sides by 2. So this becomes e to the 4 is x plus 3, or simply x is equal to e to the 4 minus 3. So when you plug in this one in there, that becomes e to the 4 minus 3 plus 3. So that's e to the 4. Square root of e to the 4 is e squared. So that leaves you 2. So this is correct. E to the 4 minus 3 is your solution set. Now in here, you can see here there is minus. So when we apply the second, this one, rule, I can say this is simply ln of 2x plus 1 all over x is equal to 2, because that's the log of a quotient. It becomes a difference. And then let's transpose. E squared equals 2x plus 1. So this is basically transformation. And then since we're solving for x, let's multiply everything by the LCD, which is simply x. This becomes e squared x is equal to 2x plus 1. E squared x minus 2x is equal to 1. Factoring out x, it's e squared minus 2 equals 1, or 1 over e squared minus 2. Okay, so when you plug this in there, it makes both positive, so there's no problem. This would be the solution set. 1 all over e squared minus 2. So this one's, the first 4 problems are quite easy. Let's try doing some more. Here, in this set of examples, ln of x is equal to negative 3. Let's just do transformation. The base is e because that's ln. X, or simply 1 over e cubed if you don't want it to have a negative power. And then that's the solution set. I'll just underline the solution sets. Number 2, let's try. Logarithm of 3x minus 2 equals 2. The base is not specified, therefore it's automatically base 10. So that's 10 squared is equal to 3x minus 2. So that's 100 plus 2 is equal to 3x 102. Let's divide this by 2, 34. And then when we plug in 34 in there, the argument is still positive. So that means it's correct. It's a solution set. Let's try the next number. Number 3. 2 logarithm of x equals logarithm of 2 plus logarithm of. So let's combine those with x's on one side. So I can see that this one is logarithm of x squared minus logarithm of 3x plus 4 minus 4 logarithm of 2. Let's combine. This one becomes x squared all over 3x minus 4 is equal to. Since both sides have the same basis, I can just say x squared over 3x minus 4 is actually equal to 2. X squared is equal to 6x minus 8. X squared minus 6x plus 8 is 0. So we can try factoring this out. X minus 4, x minus 2 equals 0. So we have two potential answers. X is equal to 4 or 2. Let's try plugging it in the original problem. If x is equal to 4, the first term is still correct because it's positive. 4 times 3 is 12 minus 4. That's positive. However, if we plug in 2, logarithm of 2, that's positive. 3 times 2 is 6 minus 4. That is still positive. So that means both are correct answers. Let's try number 4. Logarithm of x plus logarithm of x minus 1 equals logarithm of 4x. So let's combine 2 first. 2 of them. So that's x minus 1 equals logarithm of 4x. Some of you might want to move or transpose the right side to the left and make it uh, a quotient, and then that's equal to 0. It's up to you. But sometimes, you can just have one term on either side, and then so long as they have the same base, you can just equate them. So this one is x squared minus x is equal to 4x. And then transposing x squared minus x minus 4x is equal to 0. X squared minus 5x is 0. X minus 5 is 0. So x is either 0 or positive 5. Now, checking this back, one of the properties, as you can see in here, x should be greater than 0. So that means this one already can no longer be an answer. For 5, let's plug in. 5, that's okay as an answer here. 5 minus 1, it gives us 4, which is still positive. That's correct. 5 times 4, it's okay. So that means this one is what you call an extraneous root. The only solution for this one is 5. You can never have the 0 as an answer. Let's have another problem. Logarithm of x plus logarithm of x minus 3 is equal to 1. Let's combine both logs. So that's plus, so it becomes product of two logarithms is equal to 1. So on the right side, there's no logarithm. So what we can do here is do transformation. 10 to the 1 is equal to x minus 3. So that's x squared minus 3x. And then that's 10. So x squared minus 3x minus 10 is equal to 0. This becomes x minus 5 and x plus 2 is 0. Either your x is 5 or negative 2. Now let's look back. 5, that would be okay. 5 minus 3 is positive. That's okay. Negative 2. Logarithm of negative 2 is already not acceptable because here x should be greater than 0. So again, this one is an extraneous root. The only answer for this would be 5. Last, let's do number 8. Logarithm base 2 of x minus 2 plus logarithm base 2 of x plus 1 is equal to 2. So since it's plus, we can combine them as a product. X minus 2 and x plus 1 equals 2. Now, since this is one term and then one term on the right, what we can do here is transform. That becomes 2 squared is equal to x minus 2 and x plus 1. That becomes 0 is equal to x squared minus x minus 6. So x minus 3 and x plus 2 is 0. Either x is 3 or negative 2. Now looking back, 3 minus 2 gives us 1. The argument could be 1. Yes. And then 3 plus 1 is positive. That's correct. For negative 2, it's already not acceptable. This one is an extraneous root. So the only answer for this is 3. Some of you might ask, is it possible that both answers will be extraneous? Yes, so long as they don't meet the criteria that the argument is always greater than 0, it could be both extraneous. So you can have null set for the solution set. All right? Thank you very much and happy studying.